Hello. Hello. Can you hear me?
Yes, sir.
Okay. We'll continue with some theorems and then some examples. So
Okay.
this next one is called Cesaro's theorem. It says that if limit of f of n is equal to L and limit of g of n is equal to L dash, then limit of all of these limits are obviously n tends to infinity. So here also it is n tends to infinity, here also. So limit of n tends to infinity, f1 gn plus f2 gn minus 1 plus f3 gn minus 2 and so on plus fn g1 divided by n is equal to L into L dash. 1 second, just hold on. Okay, so this is the statement of the theorem. Obviously, it can be proved using the definition, but we'll not worry about the proof right now. We'll just understand what the theorem means and then apply it in problems if required. Right? So Fn is converging to L, Gn is converging to L dash. Then this is like a product of terms on the top. There are n terms here. You are taking average. And how are you taking it? Like you can write f1, f2, f3 till fn. And here you're writing gn, gn minus 1, gn minus 2 till g1. Multiplying these. And if you multiply these terms, there are n terms. You take the average of them. The limit is going to be L into L dash.
उनका जो सब्सक्रिप्ट है वो n+1 है सम मतलब सबका जो सब्सक्रिप्ट है वो n+1 है.
Yeah, it is n is linked to 1, n minus 1 and 2 and so on. So this is useful sometimes in some problems. Another theorem that we'll look at is if Fn is a sequence such that limit n tends to infinity Fn plus 1 by Fn is equal to L, where mod of L is less than 1, then you can say
Fn converges.
Then n tends to infinity, Fn limit will be equal to 0. Okay. So this condition is there. If the ratio of the n plus 1th term to the nth term limit is some L, which is less than 1 mod, right? Then the nth term here will tend to 0. It converges and it converges to 0. Okay.
Okay.
This is simple to understand, right? No issues here.
Okay.
The next one that we look at is again similar to theorem. If Fn is a sequence such that limit n tends to infinity Fn plus 1 by Fn is equal to L, but this time greater than 1, then limit n tends to infinity
It
F
will diverge.
infinity.
It will diverge.
So these two theorems are super important. It's like a ratio test. Take the n plus 1th term, divide by Fn, take the limit. If it is coming to be a value which is less than 1, limit of the sequence is 0. Otherwise, if it is greater than 1, it is diverging. Right?
Right.
Let's look at
The value L, it has to be between -1 and 1.
there it has to be between -1 and 1. First one. Right?
Yeah.
Now we'll use these two theorems, those three theorems, and try to do these questions. This one is find the value of limit n tends to infinity 2 power minus n multiplied by n square. And second one is find the value of limit n tends to infinity m into m minus 1, m minus 2, so on till m minus n plus 1 divided by n factorial x power n. Both cases you have if here if mod x is less than 1. Both cases you have to find the value of the limit.
So can we have a look at the previous slide once again?
No, you should have written them down. No, theorems are simple only. Fn plus 1 by
No,
Fn.
yes, the second one I have written limit n tends to infinity f of n plus 1 upon f of n is equal to L, where mod L is less than equal to 1, then it will converge and it will be equal to 0. And
Or,
if it is L is greater than 1, then it will diverge.
तो फिर क्या problem है?
First wala I wanted to see.
Why didn't you write that one? It is F1 Gn.
Yes, sir. Okay, so now
Is equal to what?
is equal to LL dash.
L is the limit of F. G, L dash is the limit of G sequence.
So first one is 0.
How?
Sir, with the help of, I have done it with the help of ratio test. Limit n tends to infinity f of n plus 1 upon f of n. So that will come out to be half, equal to half. So since it is between -1 to 1, hence it will converge.
Second one also has to be done by the same principle.
Same sir, वही करना बस ये होने वाला है इससे. X.
If you define Fn as
Yes sir, ये 0 आ रही है लिमिट.
how? What is your limit of Fn plus 1 by Fn?
It is coming out to be 0.
This limit should not come out to be 0. No.
Sir, f of n plus 1 upon f of n, तो
Should come out to be minus x. अगर तुम, if you have taken Fn correctly and all.
हाँ सर, यही लिया है जो दे रखा है एक्सप्रेशन, वो लिया f of n plus 1 में n की जगह n plus 1 डाल दिया, तो जो लास्ट टर्म है उसमें m minus n plus 1 हो जाएगा, यानी वो m minus n हो जाएगा.
Then why are you making mistakes then? M into m minus 1 goes on till m minus n.
बस यहीं तक. तो इस जो फर्स्ट है उसमें m minus n plus 1 तक है, यानी एक और टर्म है, इसमें एक टर्म कम है उसके कंपैरिजन में. x to the power n plus 1 को x to the power n into x लिख देंगे.
You will get this is the Fn plus 1.
यही आया सर.
What is, when you divide, what will happen?
तो सर ये m minus n plus 1 बच जाएगा न्यूमरेटर में. एक मिनट. हाँ हाँ सॉरी सर, वो डिनोमिनेटर में कर दिया, ये न्यूमरेटर में बचेगा।
You will get m minus n.
ये डिनोमिनेटर में n, लिमिट n टेंड्स टू इंफिनिटी,
You will get this part comes on top. So divided by n plus 1 factorial plus 1 factorial. All of the terms will get cancelled.
सर बट m माइनस n
Except
प्लस
m
1
minus n.
वही।
So it will simply be an n factorial will cancel with n plus 1 factorial. So you'll get m minus n by n plus 1 into x. Right?
अच्छा तो फिर x बाहर चले जाएगा क्योंकि वो कांस्टेंट है, m ने
Why
लिमिट
are you
है।
not getting x?
Sir, I was getting x, but I took it outside, and what I was getting, I was getting like I was getting m minus n plus 1 in the denominator.
That is wrong. No. If you see, how are you getting m minus n plus 1 in the this is
Sir, like m minus n will be the term left to this.
do you understand that m minus n will be
No,
left
no,
rather than
no,
this?
नहीं, हाँ सॉरी मैंने उल्टा बोल दिया। हाँ, इसके बाद आएगा m minus n, तो इसमें होगा ही नहीं वो, तो इसलिए बच जाएगा।
Limit of this tends to n infinity is what? You will divide by n.
हम्म।
It will be 1 plus 1 by n into x.
हाँ
Limit
सर,
m
-1 होगा और x बाहर चले जाएगा, -x हो जाएगा।
will be minus 1 and it will be minus x.
Yes.
And because it is given that mod x is less than 1, minus x will be greater than minus 1. Right?
Right.
So this limit will also tend to 0 by the theorem. Correct? Are you understanding why it is 0?
Yes, sir, because the limit L is coming out to be between -1 to 1.
The next thing is Cauchy sequences. Have you seen whether this has been asked or in the syllabus or something? There's an
Yes.
important part, it must be in the syllabus. So we'll discuss it. Have you heard of this before?
No, sir.
Okay, but it is important. So the definition is this. A sequence Fn is said to be a Cauchy sequence if given epsilon greater than 0, there exists a positive integer m, a positive integer m such that mod of f of n minus f of m is less than epsilon for all n greater than m. Read the definition, try to understand what is happening, try to explain what this definition, what you understand from this definition. क्या समझ में आ रहा है इससे?
Sir, एक second. Yes, sir.
So what is the meaning you understand? Given epsilon greater than 0, some value of epsilon will be given to you. You have to show that there will be some integer m such that after that, after m, always what is true? Fn minus fm is less than epsilon mod.
Sir, the like all the terms will be closer to Fn than to the like.
All the terms will be in the epsilon neighborhood of fn, or
Okay.
it is closer to fn than epsilon,
Yes.
and that happens after a cutoff point, after n becomes greater than equal to m. Beyond this, and obviously the cutoff point here will depend on the value of that epsilon.
Yes.
So if you change the value of epsilon, you will have a different cutoff point beyond which all the terms, the mod of fn minus fm for any term greater than n greater than equal to m is always less than epsilon. Beyond in this portion, right? Correct. So distance between any two terms becomes lesser than epsilon, right? Beyond the cutoff point, the terms are therefore becoming very close, right?
Yes.
If you choose an epsilon to be small, let's say 0.1, this means what? That एक particular term के बाद सारे terms have spacing between them is less than 0.1, right? Beyond n greater than equal to m, every term, any term that you pick, term number 100 and term number 500, if n is 99, if m is 99, right? No matter what two terms you pick on this side, you will always have what?
तो सर
Term
जैसे सर
100 minus term 500 mod will be less than epsilon.
बट सर हम m तो जैसे उसमें एक फिक्स कर देंगे ना, तो जैसे m99 लिया इधर लिया तो हर बारी 19 मतलब f99 से ही तो होगा, चाहे वो कोई भी हो, 500 टर्म हो, 400 तो 398 टर्म हो, पर उसमें तो m तो हमने फिक्स कर दिया ना एक।
हाँ, T100 minus T99, T500 minus T99.
हाँ, तो सर हम मतलब आपने मतलब ये कहा था कि वो कोई भी दो टर्म, तो ये तो अब एक टर्म तो फिक्स हो गया ना।
Yeah. Are you understanding what is happening?
सर थोड़ा थोड़ा। सर वो पॉइंट नहीं थोड़ा समझ में आया, मतलब कि हम m तो फिक्स कर देंगे तो फिर तो किसी भी एफ एन लें तो वो तो ठीक है कि एफ एन तो अलग अलग हो जाएगा, बट m तो वही रहेगा ना।
हाँ, कितनी बार बोलूं? हाँ,
तो सर वो ये कैसे होगा कि कोई भी दो पॉइंट्स, फिर हम तो m फिक्स कर दिया ना, वो तो हो गया 100 99, तो फिर 500 और 99, 300 और 99, 200 और 99, एनी टू पॉइंट्स के लिए तो हमें वो 99 भी फिक्स नहीं होना चाहिए ना, तो वो
ये
होना
डेफिनेशन दिख रहा है तुमको?
चाहिए कोई भी। यस सर।
जो डेफिनेशन है वो करेक्ट है, वही है डेफिनेशन.
हम्म।
Prove this. The sequence 1 by n is a Cauchy sequence.
सब ऊपर वाली डेफिनेशन से प्रूफ करेंगे.
Obviously, what else will you do? You have to use the definition to prove that it is a Cauchy sequence. Let epsilon be given positive some number epsilon. Let n is greater than m. Fn is 1 by n. So if you have mod of Fn minus Fm, that is mod of 1 by n minus 1 by m.
less than equal to less than epsilon.
This is that you cannot assume, you have to prove that. This is equal to 1 by m minus 1 by n, right?
Yes, sir.
Since n is greater than m, 1 by n
तो
is
रेसिप्रोकल में उल्टा हो जाएगा.
you can say that now mod of Fn minus Fm is equal to this. That means mod of Fn minus Fm is less than 1 by m. Therefore, pick epsilon to be 1 by m. That means m should be greater than 1 by epsilon. You automatically get mod of Fn minus Fm is less than epsilon for all right? For all n greater than m such that m is equal to 1 by epsilon.
Right.
This is equal to this, so this obviously is less than the first term.
Yes, sir.
So if you pick your epsilon as this, then for all n greater than m, you will have this true. So
Yes, sir.
that is saying that we have found our we have found this definition. We have found a situation where mod of fn minus fm is less than epsilon for all n greater than some particular value. That means that this sequence is a Cauchy sequence.
Right.
The other question was prove that this is not a Cauchy sequence. So here the terms are fn is n square. So if you take two terms, let's take fp, which is equal to p square, and f, let's say fq is equal to q square. And let's take two successive terms. So p is equal to 2m plus 1, let's say, and q is equal to 2m. So both p and q are greater than m, but these are two successive terms of the sequence. So you will get fp will be equal to p square. So it is 4m square plus 4m plus 1, and fq will be equal to 4m square, right?
Right.
Difference between these two terms, mod fp minus mod fq, will be equal to mod of minus 4m square will be equal to mod of 4m plus 1, and that is clearly greater than 1, right?
Right.
So you are getting mod fp minus mod fq is greater than 1 for all m, right?
Right.
So if you pick for a Cauchy sequence, if you pick epsilon to be half, then it will be impossible. It's impossible to find. In Cauchy sequence, you have to find situations such that fp minus fq is less than epsilon, right? For
Right.
all pq, p greater than some particular value.
Right.
So if you pick epsilon as half or something less than 1, that is impossible because fp minus fq is greater than 1, obviously.
Okay.
Basically, the point is that for certain values of epsilon, it is not possible to satisfy less than epsilon condition, right?
Right.
Because here the mod between two terms, two successive terms, is getting bigger than 1.
Right.
So that is not a Cauchy sequence because of that reason. The reason why we have to understand what is a Cauchy sequence is because a lot of convergence properties can be proven due to these theorems. So we'll look at 2, 3 theorems We'll not look at the proof, but you just need to know the theorem. The first one is every Cauchy sequence is bounded. Every Cauchy sequence is bounded. Bounded obviously means there is upper bound and lower bound. Then the second one is saying that this is Cauchy's criteria for convergence. Cauchy's criteria for convergence. It says that a sequence converges if and only if and only if it is a Cauchy sequence. So every convergence that we have seen before, every time any sequence was converging, it must be a Cauchy sequence. And if you have a Cauchy sequence, it will converge. Both sides is true. Right?
Right.
So if you can prove that the given sequence is a Cauchy sequence, then it will converge. That is one important application. And the third one is Cauchy's general principle of convergence. So general principle says this: unnecessary and sufficient condition for a sequence Fn to be convergent is that to each epsilon greater than 0, there exists a positive integer m such that this is for any sequence Fn to be convergent. We can say that for every epsilon greater than 0, there is a positive integer m such that f of n plus p minus f of n is less than epsilon for n greater than equal to m and for p greater than equal to 1. So basically he's saying that the gap between n and n plus the next term here,
Is one term.
at least one. It can be n plus 1 minus n or n plus 2 minus n, whatever. As long as n is greater than m. Right? So basically it is saying that if a sequence has to be convergent, then whatever epsilon you choose, the difference between the distance between any two terms, which are one space, two space, whatever space, between the distance between any two terms, basically, beyond a certain point, beyond a cutoff point, will be less than epsilon.
सर वो जो पहले था ये सेम चीज आ गई ना जो हमने fn minus fm में देखा था.
It's not the same as Fn minus Fm. There is a difference. These terms are not fixed. This can be gap between any two terms it is.
अच्छा, उसमें fm फिक्स था.
Basically, it is saying that the gap distance between any two terms beyond a cutoff point will be less than epsilon,
Okay.
right?
Right.
Last thing to know for theorem for Cauchy sequences is basically that if there are two Cauchy sequences Fn, Gn are Cauchy, then Fn plus minus Gn, Fn multiplied by Gn, and even 1 by Fn, as long as Fn terms are not zero, are all Cauchy sequences. Basically, this is a simple theorem that if you have a Cauchy sequence Fn, Gn is also Cauchy, then you can add, subtract, multiply the terms, even take reciprocal as long as terms are not zero. And the resulting sequences will still be Cauchy sequences. Right? Are you understanding this?
Yes, sir.
So there are questions on this, but we will do the questions once you check past year's paper and confirm if this is ever asked. But
Okay.
you need to know this much Cauchy sequence, at least basic idea you need to know. Again, you have to also check whether this subsequence has been asked. Subsequences topic ever it has come or not, because if it has not come so far, then we'll skip that and we'll move to infinite series. Like then we don't have to do that section. But if it has come, then again we'll have to discuss that then. Right?
Right.
So find out if subsequence has come or not.
Okay.
Ever.
But sir, मतलब कैसे पता चलेगा, मतलब क्वेश्चन में ये टर्म इन्वॉल्व है या फिर मतलब कैसे कुछ?
Look at the questions. If there is any term
Okay.
for subsequence, then we have to study it. If there's no subsequence ever in any question, then we don't have to study it.
Okay.
If subsequence doesn't have to be studied, then we'll start with infinite series with positive and negative terms. There are a few more things that we need to do. So we'll discuss those things then. That is the next topic. We'll have the next class tomorrow. So we'll continue from this point tomorrow.
Okay.
Okay. Tomorrow evening only sometime I will tell you.
ओके सर, आपने यूनिफॉर्म कन्वर्जेंस भी बोला था, वो भी चेक करने को बोला था, वो भी बुक करूं?
हाँ चेक करना है वो भी.
ठीक, वो भी चेक करना. मैं ठीक है फिर बता दूंगा आपको.
Okay. I'll see you tomorrow then.
ओके.